Hello dear students, welcome once more to another revision lesson on our YouTube channel. Now we are going to be looking at vector geometry, specifically for pure mathematics advanced level students. Now before the end of this lesson, you guys are supposed to know and understand the following. Alright, so first of all, you have to know the different operations in vectors. Alright, operations in vector geometry. Next, you need to know the cross, that is, you need to know the dots and cross products of vectors. Okay, now after that, you have to note you have to note the vector equation of a line in space, which means in 3 dimensions. Okay, after that, you have to note let's say the vector. In fact, from this vector equation of a line, all right, you need to deduce, let's just say, lines in space, all right, since it is a full objective. Okay, so let's just say lines in space. So we have lines in space. Then we talk about planes. All right, talk about planes. Yeah, that is all. All right, so basically these objectives have their separate objectives. All right, so these are the main things that you have to note during the lesson. If there are other things, I'm going to inform you and I'm just going to add them. All right, so basically before the end of this lesson, the learners are supposed to know and understand the following. All right, so these are the things that you have to know and understand. Okay, so if you're joining us for the first time, welcome once more to Mathematics Academy for Africa, an organization whose aim is to promote the study of mathematics in secondary schools and universities. So once more, we are looking at vector geometry for pure mathematics with mechanics and statistics for the advanced level. Okay, so by the end of the lesson, I'm going to share the PDF document of this lesson in our WhatsApp group. So if you're not there in the WhatsApp group, endeavor to join the WhatsApp group using the link in the description of this video, or you just text me directly to be added. I'm going to share my contact at the end of the lesson. Now this video might kind of be blurred in your device. Okay, so endeavor to turn on increase your YouTube resolution power so that you can be able to see the characters clearly. If the characters are also small in your device, do well to kind of rotate your phone so that you can see the characters clearly. All right, so without wasting much of your time, let us dive straight away into the lesson. Now our first objective is operations in vector geometry. All right, so I'm going to the next page. So let's start with operations in vector geometry. That is our very first objective. So for operations in vector geometry, all we are going to see is the addition of vectors, the subtraction of vectors. Okay, that's basically maybe types of vectors and so on and so forth, just to recall our little things that we know. So let's start with the introduction. All right, so in fact, let's just go directly with operations in vector geometry. That is our very first objective, operations in vector geometry. Okay, now for these operations, imagine I give you 2 vectors. So let's u and v, you see I'm writing them in bold. That's another way of writing vectors, but generally you always write them with arrows above them. Okay, so let u and v be two vectors defined by, mostly we are going to be dealing with vectors in 3D, but the same applications goes to vectors in 2D. So let me say u is equal to ai plus bj plus ck. Okay, so a, b, and c are constants. All right, that is the vector u, and the vector v is equal to, let's say, xi plus yj plus zk. Okay, so the vector v is equal to xi plus yj plus zk. Now what is u plus v equal to? Basically, to add vectors, we just have to add their corresponding components. So I'm going to write the vector u and v in their column form so that I can easily add. So the vector u in the column form is a, b, c plus, this is already a type of vector we have seen, the column vector, and the vector v is x, y, and z. So for us to be able to add these two vectors, we just have to add their corresponding components. So we have a plus x, we have b plus y, and we have c plus z. Okay, so if you want to write it as a vector, you will need the I component. All right, you will need the j component and you will need the k component. Now what is the I component? It is a plus x. All right, that goes for I. What about the j component? The j component is b plus y. Okay, b plus y. I know that you guys know this, but just for giving sake, let us be sure. And finally, what about the z component? We have c plus k. No, sorry, c plus z. That is for the k component. The same thing happens if we are subtracting the vector. So let me just put plus or minus. So plus or minus there, plus or minus here, plus or minus. So in the case we are adding, we use plus. In the case we are subtracting, we use minus. So that is it. Okay, now let us see. So basically the types of vectors we have. All right, so under the first operation, we are looking at addition and subtraction of vectors. Okay, now let's look at the various types of vectors. So types of vectors. Now we have what we call the column vector. Okay, any vector that is just made up of a single column, all right, with many rows. So column vectors, for example, let us give an example of a column vector. We just have a vector in a column form. All right, so generally, if I give if we consider, all right, if we consider this vector u, okay, this is a vector u, let us write it in a column form. So the vector u in a column form is just equal to ABC. All right, so there is just a single column with many rows. Okay, so this is a column vector. Now what about a row vector? A row vector is a vector that rather has a single row with many columns. So I have the vector a, b, c. Is it okay? Yes, that is the row vector of the vector u. Now so having the column vector and the row vector, those are two types of vectors. We also have what we call the zero vector. The zero vector is a vector whose entries are all zeros. So the vector u is maybe 0i plus 0j plus 0k. All right, so this is a zero vector. Now we also call it the null vector. Okay, and so on and so forth. So we also have the unit vector. Okay, the unit vector is a vector whose magnitude is equal to 1. So by definition, if the vector u is a unit vector, then the magnitude of u is equal to 1. Okay, All right, so I've remembered something before these types of vectors. Let us see under operations. Let us see how to find the magnitude of a vector. So magnitude and direction. All right, so let's look at magnitude. So the magnitude of the vector u, we are still dealing with the vector u above. All we do is that we just take the square root of the sum of the squares of the different components. Okay, we take the magnitude of the sum of the squares of the different components. That gives you the magnitude. Now the direction of the vector, let's consider a vector in 2 dimensions so that we are able to get the direction of the vector so easily. All right, so if I consider that the vector u is just equal to ai plus bj, all right, the direction of the vector will depend on the quadrant that the vector is in. Okay, so I'm just going to give you the formula for the first quadrant. So such that, so in this case, for you to be in the first quadrant, your x and y components are supposed to be positive. Then you are in the first quadrant. Now the direction of the vector is theta. In the first quadrant, all we do is that we take tan inverse of the y component over the x component. Okay, that is because you are in the first quadrant. Okay, now I will leave you guys to deduce if you're in the second quadrant, what is the answer. In the third quadrant and in the fourth quadrant, tell me your answer in the comment section. Okay, so this is the case for first quadrant. So the magnitude of the vector, all we have to do is to take the square root of the sum of the squares of the various components. The direction of the vector, we first of all note the quadrant it is in, and then we now get the formula. But generally in the first quadrant, it is tan inverse of the y component on the x component. In the other quadrants, this will also be taken into consideration, but now, like I said, it is going to vary per quadrant. Okay, now so I think it is good. Now if your unit vector, like I said, your magnitude is equal to 1. Okay, yes, a unit vector is any vector whose magnitude is equal to 1. Now in general, we have to note that, so let us note something under unit vectors. So the unit vector of the vector u, okay, is equal to u cap. So what we indicate is we write the vector with a cap on it. So this indicates unit vector, and by definition we need to take the vector itself. So we need to take the vector divided by its own magnitude. Okay, yes, so doing this gives us the unit vector in the direction of u. So we have to take note of this. So yeah, we have to take note of that. Okay, now I think these operations, you have taken a lot of time there, so let's just proceed to the next objective. After operations, we have dot and cross product of vectors. So that's the next thing, the dot and the cross product of vectors. So dot and cross product of vectors. Yes, that is our next objective. Now let us start with let's start with dot product. Okay, now dot product is also called scalar product. All right, so let's just write this down. It is also called scalar product. Now what it means is that if you do the dot product of 2 vectors, the result is a scalar. A scalar is any real number that you know. All right, yes, so if you do the dot product of 2 vectors, you get a scalar as your answer. Now we are still dwelling on our very 2 initial vectors u and v. Okay, so u dot v, okay, this is how we represent dot product. We have u and v and then a dot in between. So the first thing is that we need to write these vectors in their column form. All right, so the vector u was abc, okay, in the column form. Okay, and then dot. All right, the vector v is x, y, z. So how do I get a dot product of 2 vectors? I just have to write the 2 vectors in their column form, and then I multiply their corresponding component and add the result. So I'm going to have a times x. So my answer is a times x plus b times y plus c times z. Is it okay? That is my answer. The answer is going to give us a scalar because a, x, b, y, and c, z are all scalars. Okay, so definitely when I add up scalars, I'm going to get a scalar. That is why we also call dot product as scalar products. Okay, now for example, okay, let's just take an example. For example, find the dot product of 2i plus j plus k and 2i minus k. Okay, most of the times when I write I without being in bold, just so that it's a vector, okay, just I don't really have time to always be putting it in bold. Okay, so let us see what to do here in order to get the scalar product of these two vectors. So the scalar product will just be equal to, we write the vectors in their column forms, basing ourselves on the components. So the coefficient of I is 2, for j is 1, and for k is 1 in the first vector, dot. Now in the second vector, for I is 2, for j is 0, because we can't find j. Okay, so once you can't find j, once you can't find a component, you write it as 0, and then for k is -1. So you're going to have 2 times 2 plus 1 times 0 plus 1 times -1. Okay, now what is the answer going to give us? 2 times 2 is 4, 1 times 0 is 0, 1 times -1 is -1. So the answer is equal to 3. Is it okay? So the dot product of those two vectors is equal to 3. Alright, after looking at dot product, which is otherwise called scalar product, let us look at the second. Okay, let us look at the second. The second is cross product. Okay, cross product. Now the cross product of two vectors is also called the vector product of the two vectors. Is it okay? Yes. So the cross product of the two vectors is also called vector product. So it is also called vector product. In a similar way, it is called vector product because the result is a vector. Is it okay? Now, in able to do this, the prerequisite knowledge you need is how to find the determinant of a 3 by 3 matrix. Once you know how to find the determinant of a 3 by 3 matrix, doing the vector product of two vectors becomes a very easy thing to do. Okay, so imagine, let's try to do, so this is how we represent it, u cross v. All right, so this is what we do. So u cross v is equal to, first of all, we need to write, we have to create a 3 by 3 matrix where the first entry we have I, we have j, we have k. Then we impute the entries of the 3 vectors, okay, in this order. That is, we start with u, then we move to v. Okay, so for u, the first one is a, the second one is b, and the third one is c. Now for v, the first one is x, the second one is y, and the third one is z. So you see the I component is a and x for two of them. The j component is b and y, and the z component is c and k. So what we do is that we do what we call covering. All right, so I cover the first, the first row is always covered. Okay, then I now just have to be shifting the vertical lines. So we start with covering the horizontal here and the vertical. Once we cover it, we are left with a 2 by 2 matrix. Okay, so I need to put I first of all because I'm covering I. Once I cover that, I'm left with a 2 by 2 matrix. Okay, imagine covering this vertical and this horizontal. You're left with b, c, y, and z. Is it okay? So so we have b, we have c, we have y, and we have z. That is a 2 by 2 matrix in which we are going to find the determinant. Now when we move to the j component, it is always negative j. Is it okay? So minus j is what we have. So I think you just have to review how to find the determinant of a 3 by 3 matrix for you to be able to understand this perfectly. If you have not done that, endeavor to review, okay, so that you're moving alongside with us. Now, and I have to shift the first vertical line to the second vertical line. Now once I cover this, I'm left with a, c, X and Z. Is it okay? So we have A, C, X and Z. Okay, remember that when you cover J, the sign is supposed to be negative. Now when you cover K, the sign is positive, so we have plus K. Now we are also left with another 2 by 2 matrix. Okay, so follow me if you have the answer. So if I cover this, I'm now covering this, I'm now left with A, B, X and Y. So we have A, B, we have X and we have Y. Okay, now we just have to do this. All right, now we know that since this is a determinant of a 2 by 2 matrix, what we do is that we do the product of the elements in the leading diagonal minus the product of the elements in the non-leading diagonal. Okay, so we start with I. In fact, I'm going to write here at the end, then minus for J, then plus for K. So this is K, this is J, and this is I. So what is going to be inside here? I do the product of the elements in the leading diagonal, so BZ, minus product of elements in non-leading diagonal, CY. Is it okay? Now let's move to the next man. The negative sign is already outside. So what do we have? We have AZ, okay, minus CX or XC, any of them. And finally, when we move to K, we have AY minus BX. That is it. Is it okay? So perfectly, this gives us the cross product of the two vectors. Like we have said, cross product is also called vector product because the result is a vector. You see, the result is a vector. Now let us see applications of cross and dot product. Is it okay? Let us see how to do the applications of the cross and the dot product. Now you have to note that if two vectors are parallel, okay, let's start with perpendicular. So U, the vectors, so U, the vector U and the vector V are perpendicular. Let's start with perpendicular. Perpendicular if and only if the dot product of the two vectors is equal to 0. Is it okay? So this is a condition for two vectors to be perpendicular. The dot product is equal to 0. Now, what about the two vectors being parallel? So U and V are parallel if and only if, rather, the cross product, that is U cross V, is equal to 0. Okay, so I'll not bold this 0. This 0 means the 0 vector, which means that you have ijk components depending on U and V. Is it okay? So this is very, very important. All right, very, very important. The condition for two vectors to be parallel and the condition for two vectors to be perpendicular. For two vectors to be perpendicular, their dot product is 0, and for two vectors to be parallel, their cross product is 0. Very, very, very important. All right, let us look at, for example, find the value of A, given that the vectors, let me say 2i plus j and ai plus 3k are perpendicular. Yes, okay, so let's start from here. So let's find the value of the constant A for which these two vectors are perpendicular. Now all we have to do is we have to do the dot product of the two vectors. Is it okay? And we equate to 0 because we know that the vectors are perpendicular. So what is the cross product of the two vectors? So dot product. So dot product of the two vectors is equal to, let's write them in the column form. So I have 2, 1 and 0. All right, dot, what do I have? I have A, 0 and 3. Is it okay? Which is equal to 2a, is just equal to 2a. Is it okay? Now since the vectors are perpendicular, then we have that dot product, which is 2a, is equal to 0. Therefore, what is the value of A? A is equal to 0. So that is the value of A for which the two vectors are perpendicular. Now also, that was example number 1. Let us see if we can get example number 2. Find the value of A given that the same two vectors, all right, are rather parallel. So given that these two vectors are parallel, is it okay? So let's see what we have to do. So we have to do the cross product of the two vectors and equate to 0. Okay, so cross product is equal to, first of all, I create a 3 by 3 matrix. Okay, the first entries will be I, J, and K. Now I start with the first vector. You could even start with the second vector, no problem. Is it okay? Now, but that is for this case. Is it okay? Yes. So I have 2, I have 1, and I have 0. All right. Then I have A, I have 0, and I have 3. All right. Now let's do it. Now if I cover I, okay, so I have I minus J plus K. Now if I cover I, what am I left with? 1, 0, 0, 3. You can write it out, but I'm just going to give the answer. So the result will give me 1 times 3 minus 0, which is 3. So I have 3I. Okay. Now when I cover J, I get 2, 0. I have 2, 0, A, and 3. When I do it, I get 6 minus 0, which is just 6. Okay, which is 6. And next is when I cover the last part. Okay, when I cover the last part, in fact this is a bad example, bad example because these two vectors cannot be parallel. Yes, they cannot be. It's not even possible that they are parallel. So let me change it. So find the value of A given that the vector 2I plus J minus K, and AI plus half J. Okay, AI plus half J minus half K are parallel. Yes, so this is 2, 1, negative 1, and then this is A, this is half, and this is negative half. Yes. Okay, so when you do the first covering, you're actually going to get 1 times negative half is negative half, minus half times negative 1 is negative 1. Sorry, negative half. Okay, now let's go to the J components. When you go to the J components, where you cover, you have 2 times negative half is negative 1, minus A times negative 1 is negative A. Look at the way I'm writing the negative A, because these two negatives must meet to give me a positive sign. Now we go to the last part where we have 2 times half is 1. Okay, 1 minus A times 1 is A. Okay, now the result, you have to note something. Remember that this was minus and minus. Okay, minus and minus gives us plus, so you're going to have here negative half plus half, which is 0. You guys have to hold on for a while because my computer is, my word is not responding, so you guys have to hold on for a while it responds. Okay, but it's very important that these things, you try to write them down, use a previous knowledge, and you try to solve by yourself. So whenever I give an example, it's always very important that you try to solve it by yourself before you check the solution. All right, so it's possible that you pause the video, you solve by yourself, then you play the video. You could even forward the video now to get the solution. All right, and then if you failed it, you now have to watch the video carefully. Okay, I can also make mistakes, so you also need to help me in the comment section in case I've calculated something not correct. This thing is taking a lot of time to respond. So it's taking a lot of time to respond. I don't know why. So I think I will just have to pause. I'll just have to cut the video here. Okay, yes, I'll cut the video here and then continue in another video. Yes, and continue in another video because it's taking a lot of time to respond. A lot of time. This is what's even the duration of this video. This is already 30 minutes. The video is already 30 minutes. Let me see. Let me just stay like for 1 minute. If it does not respond, then I'm going to end the video here for now, and then you can check the channel again. You'll see the continuation of the video. Is it okay? So you guys should stay tuned as you watch. Endeavor to share the video with your friends. Subscribe to the channel. Alright, subscribe to the channel. Turn on your notifications so that whenever other videos are uploaded, you're going to be notified to come and watch. So it's very important that you comment on the video in the comment section. If the video is good, you comment. If you have difficulties, you also comment. Your comments will encourage us in uploading subsequent videos. Alright, so see you guys in the next video, the continuation of this video.